Hello, myself Ritu. Today we are going to study about the electric current. So let's get started. Okay, so let's start with the electric current. You must have seen the flow of water, right? So the flow of water, moving of water is called as what? Water current, right? And the flow of air is called as the air current. Similarly, when the charges flow through a conductor, that is called as what? Electric current. Fine. So you must be knowing that a conductor, let us suppose I'm taking a wire, it would be any copper wire or aluminum wire or any kind of wire. These wires or the conductors consist of the free electrons, right? It consists of free electrons, and these electrons are able to move freely in random directions, in any direction. So they are moving in different directions, right? So let us suppose I'm taking a conductor, any wire of any cross sectional shape like this. Then you can see here with the black balls, these represents the electrons which are moving in different directions. Fine. Now let us take a small area of cross section. Okay, any area of cross section of this conductor A, and now let us see the electrons are crossing this area of cross section A. So you can see in this figure that some electrons are going to the right side and some are going to the left sides. So what happens, suppose if you are taking this cross sectional area for a given interval of time t, then the number of electrons going to the right side and number of electrons going to the left side, they will add up and the total amount of charge will become zero. So let us see. Suppose if I'm taking two electrons are moving to the here, if the two electrons are moving to the right side and the two electrons are moving to the left side. So what happens? The total amount of charge passing through this cross-sectional area, okay, the number of electrons passing through this cross-sectional area for any given interval of time t, they will add up to get zero, right? Two electrons minus two electrons as they are moving in opposite direction, so it will be equal to zero. So the net amount of charge passing through it is equal to zero, due to which the no current will produced. Okay, so the current will not produce in this case. Now suppose if the same conductor I'm taking and connecting it with a battery, as you can see here. So due to the energy provided by this battery, all the electrons will align themselves in a particular directions. Now they are no more random. They all are moving in a same direction. So due to which what will happen, if we take a cross-section area of this, any cross-sectional area of this conductor for the given interval of time t, the net amount of charge will not be equal to zero in this case. As you can see here, suppose there is first, second, third and fourth electron. So all these four electrons are moving towards the left side, right? So in this case, the current will produced. Fine. So here we have seen that the electric current is produced when the charge is moving through the conductor, and the charge means the net amount of charge should not be equal to zero. So now we can define electric current. Suppose I am taking a conductor, it is connected with a battery. So the electrons, all the electrons are moving in a one direction. So if I'm taking a particular cross-sectional area of this conductor, let us suppose A, so the net amount of charge, that is Q, passing through the given cross-sectional area in time t is called as current. So we can have the definition of an electric current as electric current is what? It is defined as the amount of electric charge, that is Q, right? Which is passing through a particular area, which I have taken, suppose A, in a per unit time, right? For any given time t, if I'm calculating the amount of charge passing through the given cross-sectional area of a conductor, that is called as current, which can be also called as the rate of flow of electric charge, or we can also say it that ordered motion of the electric charge, because if the electrons will be disordered, means if they will move in different directions, then the net amount of charge will equal to zero and the current will not produced. While if it is an ordered motions, right, if all are moving in a particular direction, then only the current is produced. So here we have seen the definitions. Now let us come to its symbol. The symbol of electric current is represented by capital letter I, right? And its mathematical formula is Q by T, that is amount of charge passing through a cross-sectional area of a conductor in unit time. Means we are measuring the amount of charge with respect to the time, right? That is the formula for the electric current. Now what is we can calculate here the value of Q, right? Q is what, it is the net amount of charge passing through the conductor. So which can be calculated by this formula, that is Q is equal to N into E, where N stand for the number of electrons passing through the given area and E is 1.6 into 10 raised to minus 19 coulomb, that is the charge of one electron, right? Now let us see the unit of the electric current. As we know, I is equal to Q by T. So we can see the unit of the SI unit of Q, that is charge, is coulomb, and the SI unit of time is second, right? So the unit of current is what? It is coulomb per second, and it is called as ampere in the honor of the French scientist André Marie Ampere, right? Okay. Now see, 1 ampere is equal to 1 coulomb by 1 second. Means in this formula, if I just put the value of current as unit 1, means the magnitude of current is 1, that is 1 ampere, magnitude of charge as 1, and the magnitude of time is 1. So that is 1 ampere is equal to 1 coulomb by 1 second. So here I can define 1 ampere, right? 1 ampere is what? It is equal to 1 coulomb by 1 second. So 1 ampere is the amount of electric current which is produced in a conductor when 1 coulomb of charge is passing through a conductor in a 1 second, right? So other unit for measuring the electric current, that is milliampere and microampere, these are the smaller units for its measurement. That is 1 milliampere is equal to 10 raised to minus 3 ampere and 1 microampere is equal to 10 raised to minus 6 ampere. Now, here we can also define the 1 coulomb. As we have seen that I is equal to Q by T, right? So from here we can calculate Q. That is equal to what? It is equal to I into T, right? So I is what? It is, if I just take these values as the unit, like 1 coulomb is equal to 1 ampere into 1 second, right? So from here I can define 1 coulomb, that is 1 coulomb is equal to 1 ampere into 1 second. So 1 coulomb is what? It is the amount of charge. It is a quantity of charge when 1 ampere of current is passing through a conductor in 1 second. So hence I can define 1 coulomb like this. Now coming to the instrument which can measure the electric current, that is known as an ammeter. Okay, you can see there are different types, like different, we can have a different ranges of ammeter, like it is an ampere, microampere, or in milliampere. There is a pointer and there are scales through which we can measure the amount of current in a circuit. This is called as an ammeter, and it is always connected in series to the circuit, right? Suppose if you're having a circuit like this, we're having a switch, bulbs, cells, right? And if you have to connect an ammeter, we always connect it in the series, right? Now we are having one more instrument that is called as a galvanometer. It also consists of a pointer and a scale through which we can detect the presence of the current, right? If you have to measure the amount of current, we are using ammeter, and if you just have to detect the presence of current, we can use the galvanometer. Now let us discuss the direction of the electric current. So earlier the scientists believed that the direction of electric current is along the direction of the motion of the positive charge, because they thought that electric current is produced due to the motion of the positive charge. But after the discovery of the electron by J.J. Thomson, it was observed that the electric current is not due to the motion of the positive charge, but it is due to the motion of the electrons. Okay, so the direction of the current from positive to negative, okay, that is called as the conventional direction of current, which is opposite to the direction of the electrons, that is actual direction of the current, right? So we can say that the direction of current, the conventional direction of current, is from positive to negative, which is opposite to the actual motion of the current or actual motion of the electrons, right? So this was all about the electric current. So now let us discuss some questions based upon the electric current. So we have the first question, that is, what is the SI unit of electric current, right? So the SI unit of electric current is ampere. Coming to the second question, which device is used for measuring electric current? So the device which is used for the measuring of electric current is ammeter. Now we have one numerical based upon the electric current. So let us solve it. Here, what is given in the question, that an electric charge of 240 coulomb. So first we will write down what is the given quantity? That is 240 coulomb is the amount of charge it is given. It flows through the cross section of a conductor in unit in 1 minute. Okay, so the time is given, that is 1 minute. We will convert it into SI unit of the time, that is 1 minute is equal to 60 seconds, right? Now find the amount of electric current. So here we have to find out the amount of electric current flowing through this conductor, right? So here, Q is given, the T is given, and I we have to find out. So we know the formula for the current, that is Q by T. I is equal to Q by T, right? So Q is how much? Q is given, that is 240 coulomb. And the time is given how much? It is given 60 seconds. So we can just solve it, 24 by 6. So we will get 4 ampere. It's the current. Fine. So this way we can solve the numerical based upon the calculation of the current, right? So here we have 4 ampere as our final answer. Now let us do the another question, that is calculate the amount of charge. So here we have to calculate the amount of charge passing through a lamp in 1 minute, right? So the time is given how much? It is given 1 minute, which we can convert into second, that is equal to 60 second, right? Then current is given how much? 220 milliampere, right? So it is also given in milliampere. So first we will convert it into its SI unit. So we know that 1 ampere is equal to 10 raised to 3 milliampere. So we'll convert it by multiplying with 10 raised to minus 3 ampere, right? Now we have to calculate I. So we have the formula I is equal to Q by T, right? So here T we can write down. Here Q will be equal to how much? It will be equal to I into T, right? So the I is given, T is given. So we just put the values and we can get the answer for it, right? I is how much? It is 220 into 10 raised to minus 3 into T. T is 60. So just solve it and we can get the answer. Fine. Okay, so I have the final answer as 13.2 coulomb is the final answer. So I hope you understood this topic very well. Thank you very much.